Welcome to Brain Vision.
In this problem, we're looking at a couple of popular medical diagnostic techniques. One of them is the MRI, and the other we'll look at is PT, or PET scan. MRI is magnetic resonance imaging, and it uses an electromagnetic wave with a frequency, F, of 6.38 times 10 to the 7 hertz. While the PET scan is also an electromagnetic wave, but it's using a wavelength of a frequency of 1.23 times 10 to the 20 hertz. We're given the frequency for each of these, and what we're trying to find is the ratio between their wavelengths, ratio of the MRI wavelength to the PET scan wavelength. Now you might recall there's a simple equation. I always remember it as V equals lambda F, that is the velocity of a wave, is equal to the wavelength times the frequency. We can rearrange that a little bit to solve for lambda, the wavelength. And then by plugging in the velocity and the frequency, we'll be able to solve for those. Because these are both electromagnetic waves, EM waves have a velocity equal to c, which is 2.9979 times 10 to the 8 meters per second. And we're going to divide that by the frequency. So if we plug that in for the MRI, 2.9979 times 10 to the 8 meters per second divided by the frequency that they gave us, 6.38 times 10 to the 7, and that's in units of hertz. But you might recall that hertz are also equal to 1 over second, or seconds to the minus 1. I'm going to write it as 1 over seconds, and then we'll see that our units then here and here, meters over seconds, 1 over seconds, those cancel out, and what's left is just meters. Plug that into your calculator, you're going to get something about 4.699 meters. Now we just have to do the same thing for the PET scan, using that same equation for wavelength, the velocity, the speed of light, 2.9979 times 10 to the 8 meters per second. Divide that by the frequency they gave us for a PET scan, 1.23 times 10 to the 20 hertz. As we saw before, the hertz cancels out, and what you're left with is about 2.437 times 10 to the minus 12 meters. So the PET scan has a much higher frequency, and therefore it has a much smaller wavelength. If we go over to this equation now, we can go ahead and plug in our values. Wavelength of the MRI, 4.699 meters, divided by wavelength of the PET scan, and you'll get something about 1.93 times 10 to the 12 meters. So we see that the wavelength of the MRI is a couple trillion